We are, come on, we are live. There we go. Okay, so today's review day. It is February 4th, 2020. Okay, so simplify, have positive exponents. So for me, when I see a negative exponent, I know they're on the wrong side. So first thing I do is I think about a fraction bar. I just go straight to a fraction bar. And if it's a negative exponent, I need to move it to make the exponent positive. So, all right, I'm going to move 4 to the negative 3 down. I get a 4 to the positive 3 down here. Y to the negative 1, that's got a negative exponent, so I'm going to move it up. It's on the wrong side, make it y to the positive 1. And what's anything to the 0 power?
1.
The number 1, so I'll put a number 1 here, okay?
So would y to the positive 1 just be y?
Yeah. And in fact, Raleigh, great question. In fact, even if I just...
be y the way we did multiplying it by 1.
Yes. Yes, yes. So how about just y?
Yeah.
Yes, a 1y and a y, same thing. And 4 times 4 is 16 times 4 is 64.
So the negative 1, y, or would it be negative 1?
It would be a y to the negative 1. You got to bring it up, make it a y to the positive 1, right? Thanks, Gloria.
So 1 over 64.
Okay, so I've got y over 64. There it is. Thumbs up. Let me see. Sideways. Okay, all right, let's keep going. Okay, number 2, we have the same dilemma. So if I see a negative exponent, I think fraction bar, right? And then I wind up with a 2 to the positive 4, because I bring the negative exponent down, over a 2 to the 3, right? So this is kind of a, not too bad, but if I think about it, what I have is 2 times 2 times 2 over
8.
2 times 2 times 2 times 2, but 3 of these 2's can cancel 3 of these 2's, right? Just cancel. So it's only 1 2 left over. Where would the 1 2 left over be? If 3 of these cancel 3 of these, where would the 1 2 be left over? On the bottom. What goes on top? On the numerator?
Wouldn't it be 1/2?
Yeah, 1/2 is right. Absolutely. Now, there could be another way to do that, and you could add exponents.
Couldn't you just solve it and then just simplify it?
Yeah, you could do that too. Absolutely. You could do 8 over 16, which is 1/2. Yes. Well said. Okay. Number 3, a little bit like our warm-up. I see a negative exponent. You guys see a negative exponent, right there? So the first thing I'm going to do, we have a rule. If you have a negative exponent, I can flip the exponent, okay? I can flip the fraction. So I'll rewrite this as a 2a to the 3rd over 1 to the 5th power. We have to be a little bit careful because the 2 is a regular whole number, and the 2 also gets the 5th power. So do not make this 10. This is not 2 times 5. This is not 2 times 5. In fact, it's 2 to the 5th, a to the 15th, over 1 times 1 times 1, okay? So 2 to the 5th is not 10, is it? What's 2 to the 5th? 32. 32. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So it's going to be just a 32a15. Okay, let me see. Thumbs up. Okay. Good. All right, number 4. Well, the bottom in this fraction, the bottom part of the fraction, the denominator, is the root, and the top part of the fraction, the numerator, is the power. So I'm going to go the cube root of negative 27 squared. Okay, this is the one like Malachi did. Okay.
Can't we just not put the negative because it's...
Right, it won't matter because you're going to square it anyway, right, Penelope? Because a negative times negative is positive. So the cube root of negative 27. So what times what times what makes?
9.
3.
You're ahead of me. Negative 3. You're ahead of me, Raleigh. You're totally ahead of me because then I do get a 9 because I get a negative 3 squared, which is 9. Nice job. Okay. Okay. 5. Again, whenever I see a negative exponent, I think I've got to make a fraction. So I think a fraction bar, okay? Now the 12 is just 12. Technically 12 is on the top or in the numerator. Leave it where it's at. But the x to the 7th, I'm just going to bring down. X negative 7 becomes x positive 7. The y to the 6 has a positive exponent. Leave it where it's at. And I don't think there's anything else I can do. I think that's it. Okay. All right, number 6. 2 ways to do it. Really, we can move it first. You want to move it first?
Yeah.
Okay, let's move it first. Fraction bar. So the -4, it's a -4, but what is the exponent? Wait a minute.
Negative
What's the exponent right? Do you see it? Oh, it's invisible, isn't it? It's invisible. What's the exponent right there? 1. Am I going to move the -4 then? No, keep it right there, okay?
So it's.
But it has a -2, so you.
Oh, let's back up. Okay. The x has a -2, right?
See
So
what
I'll
x
move just the x. Good job, Riley. Yep.
And then cube it all.
Yeah, you're way ahead of me. I like that. So I'm going to bring -4 stays. X to the positive 2 comes down, and then I'm going to cube it, is what Penelope said. I totally agree. So if I cube it, I'm going to really get a -4 cubed over an x squared cubed, which is x to the 6th, because it's x squared times x squared times x squared. Okay, let's go back up to this. What is -4 cubed? -4 times -4. Positive 16 times -4. -64. Up over x6. Okay, give me a thumbs up.
Wait, what is that say?
That's a terrible -64. All right. Okay, number 7. Okay, let's look at number 7. I'm going to put it on graph paper, and there's 3 features I need. I need the correct shape, I need the correct y-intercept, and I need the asymptote, okay? So number 7. All right. I don't have to have a ton of detail for now, but I need the right shape. So it has a y-intercept of -5. 1, 2, 3, 4, 5. Okay. And I'm going to double it. I'm actually going to double it. So I'm going to go from -5 to -10.
Wait.
Yeah, I'm actually going to double it. So -5 to -10. See how it's going to go down? From -10 to double -10 to double that -20. Okay. So
It'll just go straight down.
yeah, well, yeah, it's going to go pretty steep. It's going to come crashing down pretty hard, isn't it? Okay.
But you can't know for sure where, like, the points are.
Right. We could get a lot of detail. All I need for right now is the shape. Okay. Do you guys agree it takes a dive?
Yeah.
Well, what's happening here? Is it going to cross?
No.
No.
You sure?
It will never
How do you convince me it's never going to cross?
Because it's always moving halfway there.
Well, I can't tell that. What can I put on my graph? What feature can I put on my graph?
The asymptote.
Yeah, let's put an asymptote. Because if you put the asymptote, it says, hey, wait a minute. I've got this invisible border. I've got an asymptote at y equals 0, which is an imaginary border that says you will not touch that line.
But if it's slowly going up, how come it doesn't?
If it's slowly going up, it's going to be, okay, one more time. It's like the half of a half. Half of a half of a half. Half of a half of a half of a half. Will I ever get to 0?
No, never, ever.
Never. It just keeps getting smaller and smaller and smaller and smaller. Okay. All right, number 8. So is this one going to be growth or decay on it? Number 8. Okay, I heard decay. Now, why did she say decay? I agree.
Is it going to this?
It's going to be half, right? So we take half of it. So what's my y-intercept? So if it's 48, I'll go 10, 20, 30, 40, 50. Again, I need 3 features. 3 features. I need the y-intercept, I need the correct shape, and then I need my asymptote. So it's going to have a y-intercept of 48. Half of that, half of that, half of that. So the graph is going to have a shape like this.
How come the y-intercept isn't on the other side of the fence?
It's supposed to be right here at 48.
No, I mean, like, in y, because am I supposed to be? It should be, so it should be after that.
Right, and that would be a linear straight line, you're right. It says these are exponentially different, aren't they? Right? Yeah, Riley?
Wait, would you divide 48, 5.5 to get that.
Yep,
covered.
yep, and so I'm at 24, so it should be really technically 24 here, and then 12. And so if I wanted a more accurate graph, Raleigh, I like that. You said that if I want a more accurate graph, I can get some points. You're right. Half 48 is 24, half, 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 okay? All right, now, before I move on to number 9, tell me on both 7 and 8, what's the domain on both of these? Yeah, all real numbers. Every possible x is in the domain, plus how wide is this graph? It goes forever in both directions. So x is all equals to all real numbers. Now what about the range? You reach for your range. Number
Greater
7.
than 0.
Okay. 8 is y is greater than 0. I totally agree on 8. 7 is y is less than 0 for my range. Okay. Okay, now if you're still confused with range, watch. Right? Don't mess with my domain. Right? It's my domain. And reach for your range. Okay? If you reach for your range, how high up or how far down does it go? Okay, let's do number 9. Okay, so what do you know about 9? What do you know about 9?
It's, what?
Oh, it's absolute value.
It's absolute value, which is a V. Right? Absolute value is a V. So where's the vertex of number 9?
2, 5.
It is a positive 2, 5, because it is the opposite of the inside. Has to be the opposite because that's the value that zeroes it out. Okay? So what's the slope of my absolute value graph?
Up 2 over 3.
Perfect. Up 2 over 3. So we go ahead and put this down. So I'm going to go to my vertex, which is 2, 5. 1, 2, 3, 4, 5. I'm going to then go up 2 over 1, 2, 3, up 2 over 3, 2, up 2 over 3. Okay, there it is.
I always forget to do the other one.
Yeah, but you won't tomorrow because you get good notes, right? Domain? Domain, what's my domain? How wide is this graph?
Wait, up 2 over 3?
Yeah, that's my slope, Raleigh. Good
Oh,
question.
So that's just like
Domain or all numbers?
Good. What's my range?
Y
is
is
greater
8.
than
Y is
What's its height? 5, right? Y is greater than, or it does equal it though, doesn't it? 5, all right? How am I doing? Okay, let's get to 8, the piecewise graph. Yeah, these are fun, huh? I like piecewise graphs. So, if you have a difficult time with piecewise graphs, here is the first thing you have to do, is put in your border lines first. All right, let me put my XY axis before I do anything. Okay. All right, put that in, and put that in. Okay, so, put these values, these are your border lines, put those in first, okay? So, those are x values, because it says x. So on the x-axis, I want to put a borderline on 4, 1, 2, 3, 4, a borderline at 2, and a borderline at -2, okay? And they're invisible lines, but I like to put them in, even though they are invisible lines. They're kind of like asymptotes, aren't they? They're borderlines, right? So even though they're invisible, I like to put them in there. So here's the deal. Am I going too fast? This first graph is in between 2 and, so this is a little bit backwards. So this first graph is in between 2 and 4. It's in here. Y equals 2. Horizontal line, right? At a height of 2. Okay? But I only want it right in here, because I have it between 2 and 4, okay? So instead of drawing the whole thing all the way across, I just draw it in here. What can you tell me about open and closed circles?
Open
Open
at 2.
at 2.
And close it.
Good, because you've got no equal and you have equal. Very well done. Okay, so I'm going to go open at 2 and closed at 4. Awesome. Okay, second graph. I'm going to use my pencil because I'm going to have to maybe erase something. So this has got an invisible start at 0, right? Plus 0 on the y-intercept. So I start at 0. I'm going to go up 3, 1, 2, 3 over 2, up 3 over 2, down 3, back 2. So my graph looks like this, but I don't want all of this. I want this second line between -2 and 2, right? Which is right in here, okay? Second line between -2 and 2. So I'm only going to put this part of it here. Okay, and I'm going to erase the rest. Okay, what can you tell me about open and closed circles?
-2, it is closed.
Good job, Penelope. Close there. What else do you know?
That 2 is open.
Good. Awesome. Perfect. Okay, then finally. Yeah, go ahead. Question?
No.
Finally, -2. Oh, I'm sorry. Y equals -4, okay? This, y is at -4. That means y is always at -4. So your line right at -4. But this one only goes from here back. This exists from -2 back. So we're going to go from -2 back. And there's my graph.
That's -3.
Oh, my goodness gracious. Thank you, everyone. It's a good thing I never make a mistake. Uh-oh, Mr. Hoya's here watching me, too.
And it's an open circle.
Good thing I own whiteout, huh? And Penelope, you're right. It is an open circle. There you go. All right. Got it. Thumbs up. Thank you. It's okay. We can all admit I do make mistakes. What about this f of 0? What about this f of 0? Okay. Find f of 0. So there's two ways. 0 would fit as next value there, correct? So it means I plug it in here. 3/2 of 0 is. So the answer is 0. But look at this. Here's my x. Here's my x's. Here's x is 0. What's the value here?
0.
Both work, right? I like that. So we get a visual as well. So I'm just going to go f of 0 is equal to 0. Okay? Thumbs up? Good. Nice job, Damien. All right, we're almost done. Okay, number 9. We're going to find the inverse of this and graph the inverse. So I'm going to graph both. I'm going to go ahead and put my xy axis down. We are close to being done. We are going to be in 10:05. Whew, let's see here. How are we going to do? All right.
Are we at number 9?
Yeah, that's what we're doing right now is number 9. Did I say 10?
The numbers are messed up.
Yeah,
Because there's 2 number 9s.
yeah.
Number 9s.
I know. You think a math teacher could count, right? Actually, what I do is I take the test and I modify the test for the review, so you know that kind of gives you some hint. Okay, so I'm going to start at positive 1. I'm going to go down 1 over 3, down 1 over 3. Here's my original function, right? That's f of x. Okay, how are we going to do the inverse? How are we going to do the inverse?
You flip all the numbers.
Yeah, and I think if I flip all the numbers, I think it's easier just to flip these two. Watch. So that's it. 3, 0 becomes 0, 3. This 0, 1 becomes 1, 0. So if I flip this, in fact, I'll put them up there so you can see it. I think that really, you can flip them all, but only 2 points. You only need 2 points, right? You only really need 2 points. So this is at 3, 0, which becomes 0, 3, right? This point is at 0, 1, which becomes 0.10, right? Which is here. If I connect the two dots, there's my inverse, okay? Now, can we come up with the equation of that? F inverse of x equals, well, let's see. Down 3 over 1, down 3 over 1, so it's a negative 3 over 1x plus 3. And I think somebody once said it's the opposite of that slope, right? And negative 1/3 becomes negative 3 over 1. Awesome.
But not negative, or not the opposite.
Right, the y-intercept changes. You gotta be careful on the y-intercept. Good point. Okay, we're almost done. 10. So you buy a car for $12,599, and it has a yearly depreciation rate of 8%. Okay, so red function represents this over time. It is exponential because it is going to decay exponentially, okay? So let's start off with y equals a 1 minus r to the t. And I'm going to highlight what I did, okay? Minus because of depreciation. Does that make sense? I'm going to subtract out the rate because it's getting smaller. So then I'm going to go y equals 12,599, 1 minus 0.08, because 8%, we move the decimal 1 2 places to the t power, okay? And you can leave that answer, that's fine. You can. If you want to get crazy and make it y equals 12,599 times a 0.92, same answer, right? Same answer? Right? Okay, now, value of the car after 2.5 years is a time, right? You guys agree with that? It's a time. So I'll put 2.5 there. So I'll go y equals 12,599 times 0.92 to the 2.5 power. And I've got to make sure we have good calculators tomorrow. I'll track them down. I'll let Mr. Bard know, and Mr. Clarich, that I need the calculators tomorrow. To the parentheses, can you see what I'm doing with my calculator? I'm just going to go, I'll go 1, subtract 0.08 to the 2.5 power, and I get an answer of 10,228. So I get $10,228.35, right? And now,
Why'd you add the 2.5?
oh, this question. That's t. So I'm going to use, here's my equation, right? Let's use my equation. So my,
Times the answer
it's exponential, so you gotta put it up here, right? Yeah. Now, how do I figure out 3,000? How do I figure out 3,000? Okay. So one way is guess and check. So here's my equation. I've got y equals 12,599 times 1 minus 0.08 to the t. Now I'm going to show you another way. So you could guess and check, guess and check. And if we have graphics calculators, I'm going to show you a trick. Okay, it's the last little trick I'm going to do. Okay, I'm going to go to y equals, and I'm recording so you can always watch this later. Okay, and I'm going to go 12,599 parentheses 1 minus 0.08 to the x power. I won't do t. Okay, it just says x. Okay, and I'm also going to go 3,000. Okay. Now the funny thing about these calculators is I need a window to make it work. So let's use some common sense. Window. Think about window. Window's the size of the graph, right? So we haven't talked about this yet, but we're going to start talking about the graphics calculus more and more. Okay. So think about the window. Okay. So this is a car. We're going to buy it. We're going to let the minimum be 0 because it's brand new. Okay. Woohoo! It's brand new. So year 0. Okay. 0. We bought it. Now how many years do you think that car is going to last? 20 years, okay? X max, 20. Does that make sense? 20 is a great guess. After 20 years, it's probably going to be too old to drive, right? Unless you take care of it, okay? Now, the X max. Let's look at the X max for the X min. So what's the car worth right now? 12,599, right? So my X max has got to be right around there in this drop, right?
I mean your
So
Y
maybe
max,
we'll
right?
Yes, you're right. Thank you, Malachi. 13,000? How about 13,000? That's my max. 13,000. And my min's got to be at least around 3,000, so I'll put just 0. I'll put it 0. Okay, whoops. I'll put 0 here. It'll never be worth $0. So let's graph this. Okay, here's the car. It's dropping in value. It's dropping in value over time, and there's the 3,000. So if I can find out this intersection, I got the answer, right?
Yeah, how do you find that?
Great question. So in this little blue button here, it's called calculate. There's all sorts of cool things here. So I'm going to go second, calculate, right? And we're going to keep learning this, okay? So second, calculate, and there's an intersection button, okay? See that? So I go to intersection, and I'll say, okay.
Why haven't I known this my whole life?
I don't know. We're going to learn a lot about these calculators. They're pretty good. These calculators have a lot of stuff, okay?
I would have helped so much last year.
I know. Enter, enter, guess. You don't really need to guess. It's a feature on the calculator that makes you guys think, oh gosh, I think it's right there. Yeah, it is. Boom, there it is. It's exactly at 17.2 years is where it would where the value is 17.2 years. Okay. Now I'm going to stop recording and